leveraging AWS services like Amplify and CodeBuild for Next.js front-end and then Python Flask back-end applications without any infrastructure maintenance. So I am Sandu Park. I'm working at Stanford University UIT as data engineer, and then can get started. Okay, so a little bit about me. I've been in the data engineering industry for more than 5 years now. And among many other things, I am specialized in data ops, data architecture, data security. And as you can tell from this bio, I am by no means a full stack developer or front-end developer, but here I am. So let's find out why I'm here today. But anyway, I'm committed to building a solution for a better developer experience. So anything ranging from, Git branching strategies. So building we're developing a Git branching strategies for multiple Git users on the same repository, and also any CI/CD scripts that runs automatically to reduce any of the human intervention into the integration and the delivery, and also any infrastructure automation deployment like Terraform scripts. Yes, I'm doing that for my team. So today's agenda are very straightforward. First, why repository agnostic CI/CD? Why is that important, and then why my team is implementing it? Next, Next.js frontend with Amplify, why we are choosing Amplify for the Next.js frontend. And third, why we are choosing CodeBuild for the Python Flask backend. And then at the end, the most important thing, the live demo and some takeaways. So the pain point. At Stanford, traditionally, we were using self-hosted GitLab for a long time. And then only very recently, we got an enterprise license with GitHub. And now, as a Stanford developers and Stanford students and professors and researchers, we have two options as a Git providers. So GitLab, self-hosted, Stanford-hosted GitLab versus cloud GitHub. The problem is each platform has their own CI/CD tooling, meaning that it has their own runner system, has own credentials management, webhooks, and etc. So even though they started using GitLab or started using GitHub, if they start using both of them, then they have to manage two different CI/CD tooling. The second one is, which is based off of first one. So they need to actually learn different YAML syntax and semantics for each provider if they want to utilize this CI/CD tooling for different providers. Third, traditionally with the GitLab self-hosted option, a lot of users, including our team, have been self-hosting our own CI/CD runner for GitLab. That means a lot of heavy operations and also maintenance overhead in order to maintain the runner. So we had to actually spin up the EC2 instance, install Docker inside the EC2, make any patches on the EC2, and also manage any memories or CPUs on the EC2 when it comes to the runner if it's getting used by a lot of different repos. So there is a lot of heavy maintenance, heavy ops when it comes to the self-hosting runner. And also, even though you're using GitHub Enterprise version, still there's a limitation, which is GitHub Managed Runner has limited minutes allowed. So the more users we have, or the more repos we have under GitHub Stanford Enterprise license, that means we are going to have less and less minutes allocated per repository under GitHub. So that was the uncertainty that my team wanted to avoid. The result is, with this pain point, a lot of teams spend more time actually babysitting CI runners rather than shipping actual features. So this is exactly the opposite of a modern and agile workflow. Yes. So what we are doing about this, our our team's approach is, okay, let's go with AWS, and anything with AWS managed or integrated, let's embrace them. So you can actually build one CI/CD pipeline, which can be used across any Git providers like GitHub, GitLab, Bitbucket, or you name it. And also, since we are a data engineering team, we wanted to have any services out of the box. So fully managed integrated AWS services like AWS Amplify and AWS CodeBuild are the services that we chose. And also enterprise compliant. So all of these services provided by AWS are enterprise compliant. So that's why it is acceptable within the Stanford environment. So high-level architecture, I just put the very basic overview architecture for our front end and back end. So as you can see from the top, that's our front end architecture, which is very straightforward. We have a repository in GitHub for the front end. And then we have Amplify on the right hand. And the integration actually happens over SSO. There's no manual connectivity setup or anything like that. You just go into Amplify, type in your repo URL, and then it's going to automatically trigger SSO integration. And once it's set up, then all of the setup is automatic. So there's no even any webhook or any listener setup needed for Amplify. Whenever there's a new code commit or push events happen on the repo level, that is all going to be forwarded to Amplify automatically. So there's no need to set up that either.
So
yes.
What is the SSO GitHub to AWS, or I mean, it's not Stanford SSO, your SUNET ID.
Yes, that is a SUNET ID SSO.
It is Stanford?
Yes. Yes, because when you connect to GitHub front-end repository using Amplify, we are providing specific URL for our organization under GitHub. So when we provide that in the URL, it automatically redirects us to the SUNET ID SSO, and that's how we get authenticated through that. Yes. And then on the bottom side, there is a slightly more complicated architecture for the backend. So now we actually have to have a webhook. So if there's any new commits committed to the repo for the backend, or push, or MR merged, or whatever happens in the repo, that has to be actually be forwarded to the CodeBuild. And CodeBuild, luckily, is able to provide out-of-the-box webhook. So when you actually set up CodeBuild, so it's if you think about it, it's just a CI/CD runner, but fully managed by AWS. So we don't have to manage anything. We don't have to worry about EC2 or anything. It's just a service that you choose with a CPU and then memory, and that's it. And then once you complete this setup, then there's an option to also set up the webhook. So webhook URL will be provided automatically when you set up the CodeBuild. And you can just provide that information to the GitHub so that whenever any events happen within the GitHub, it will send that message to the webhook, and the webhook will trigger a CodeBuild. So I'll go more deeper in the live demo, but also it is a SSO integration enabled. So once the CodeBuild receives a message from webhook, then what it does is, based on the CI/CD script that we write, it's going to actually build a Docker file, because our backend repo has Docker file stored. So whenever the CodeBuild actually check out to that repo and then start building, it's going to build a Docker file. After building it, then it will register it to the ECR. Once it's registered, a new image is registered in the ECR, then it's going to be used by ECS Fargate. Then ECS Fargate will spin up that task container, and then that container will start forwarding or listening to the port number provided by application load balancer. And this ALB is the entry point for Amplify, the front end, to send any API call to, and they receive the message back. And there's a backend Flask app that we build, and that is the one that talks to the Bedrock. for any LLM use cases. So why we chose Amplify for front-end CI/CD? There are a couple of reasons. The very first reason is, so by any means, I am not a full stack or front-end developer, but sometimes for business use cases, my team sometimes has to provide data insights or data value through a website. So that's the reason why we had to actually build a website and serve multiple users, actually quite a scale. So any type of maintenance in terms of website infrastructure, we had to avoid it. So easy Git provider integration and auto detect branches and push events comes with Amplify automatically. So that was a no-brainer. And also there's no CI/CD config file at all. When you actually write CI/CD script for GitHub or GitLab, you have to actually start with checking out to that specific repo and then build and then deploy artifacts, storage, and things like that. Here, we don't have to do any of that. It's just the one simple Amplify YAML file that defines what is the build command, and that's it. Also, zero config provisioning of a global CDN. So Amplify comes with global CDN. So we don't have to worry about CloudFront or anything like that. It just comes with it. So that was a one plus for us. And also one-click branch to environment mapping. So if we want to have or maintain multiple different environments for this website, then the easiest way to do using Amplify is we just create a different branches under GitHub repo and then map it to the Amplify, and then it will recognize it as a different environment. And then we can specify one specific repo branch as a production environment, and it will treat it as a production environment. And lastly, but not the least, is the built-in secure authentication flows. So any sign in, sign up, forgot password, those type of things comes with Amplify. Very few lines of code, and you write it in your code, and then it's going to be able to do all these secure authentication flows for you. Yeah. So these are the reasons why my team chose Amplify for the front end. Then let's go to the back end. Okay, so why we chose CodeBuild for the backend? So same thing, so easy Git provider integration, SSO integrated with a Stanford Sunet ID, and also built-in push events listener via webhook. So it comes with webhook. And then once we provide this webhook URL to the GitHub, GitHub will automatically send any events, push events to the webhook, and then it will trigger the CodeBuild. And also there's no need to set up or manage or patch any of our build servers. It is fully managed by CodeBuild. And third, it can automatically scale capacity. So builds don't need to wait in a queue to run. Sometimes when you run your own CI/CD runner, then depending on the size of the runner, so size of the compute or size of the memory, sometimes your build job has to wait in queue. But with the AWS CodeBuild, which is serverless, your build job don't need to wait in a queue anymore. It's just going to run in parallel concurrently with all the scales you need. And then single CI/CD config file, regardless of a Git provider. This means that if one day you are using GitLab, next day you're using GitHub, you don't need to write different CI/CD config file for different Git provider. You just write a CI/CD config file for CodeBuild once, and then you can just store that in a different Git provider repository, and it will still work because it's not bound to any specific Git provider. It's only a matter of connecting your CodeBuild to your repository. And then the last one is there's no fixed cost about CodeBuild, which is good thing about serverless, right? You pay only for the build minutes that you use. So unlike CI/CD runner that you spin up in EC2, you actually if you do that in EC2, then you have to pay like monthly fee, right? Because the regardless of CI/CD runs, the EC2 instance has to be up and running 24/7. But with this CodeBuild case, you only pay for what you use. So you pay as you go model. So now we, with these 4 characteristics, shareable pipeline YAML file, then swap Git provider easily, no runner maintenance overhead, and SSO across platforms. With these 4 characteristics, now you have a repository freedom. You can go to any repository you want. You can move from one repository to another repository without worrying about, okay, do I need to worry about the YAML file, syntaxes, semantics, anything like that? No, you can just do it instantly, yes. So now the fun part, we have a demo. So unfortunately, my team is currently working on this specific website, but we are not able to share it publicly. So I just came up with one demo website, which is a fortune cookie wisdom web app. What this one is, so you can try out yourself by scanning this QR code, or I can do it myself. So this is the fortune cookie wisdom generator. So when you put your mind or any thought into this input bar and then hit get wisdom, it's going to send API call to the backend, the Flask backend. And then it's going to talk to the Bedrock, AWS Bedrock for LLM use case, and then generate this customized, highly customized fortune cookie wisdom, and then give it back to here. So let's try out here. So maybe we can say web hosting. Yes. So yeah, well, with the web hosting, your digital dreams need a strong foundation. Choose your web host wisely. Yes. There could be some, doubt about whether this is a wisdom or not, but anyway, this is how this demo website is currently working. And now the demo that I want to show you is, so this is the front-end repository that I have under GitHub. And this is the backend repository. So what I will do is I'm going to update one change in the front end and one change in the backend real time using VS Code. And after a few minutes, after it automatically deploys all the changes to website as well as the backend, then we'll come back here and then try again to see any differences. Okay, so right now I have prepared, maybe 1 second. So this is the front-end repo in my VS Code. And what I'm going to change is I'm going to, right now, when you put your wisdom, when you get your wisdom right here, you don't have any fortune cookie emoji here, right? So that's what I'm going to do. I'm going to add fortune cookie emoji right here. And then I'm going to push this change. Okay, and then I'm going to show you what happens after that. And then also what I'm going to do is with the backend, I'm going to do add as a, one small change as a R-rated content. Okay. So now whenever we prompt on the input bar, then it's going to get a fortune cookie emoji with it whenever we get the wisdom back. Also, the content of the wisdom will be now, instead of PG-13, it's going to be R-rated. Okay, so let's go back to the Amazon. So now let's see. Yes, just committed, right? On the front end repo. Yes, now it was committed. Now let's go here and then check. So this is Amplify AWS console. And then the minute we make any changes and then push it to the repo, now it has been captured by Amplify and then it's deploying it. And then if we want to see what's happening with the build and the deploy, it's all right here. You can actually see those logs here. At the same time, with the code build, when it comes to the backend, you can actually see it was captured by the source version, and then this is the submitter, and then how long it's actually taking. So if you take a look at this, and these are the build phases. It is, building the Docker file, registering to the ECR, and then pulling it from ECS Fargate and then updating the task. So that is what it's doing. So the backend CI/CD has been completed just now. And then it takes slightly more time for the front end, but should be done in a minute. So it takes about 3 minutes. Okay, yeah, so that is currently working. So let me go ahead and then refresh. Right now, there's no emoji here, but after this CI/CD for the Amplify completes, then you should see an emoji here. So let's check it out. So while it's running, does anyone have any questions? I know we have a Q&A session at the end, but
it's by definition deploying to the AWS platform. You're not using this pipeline to deploy to like GCP or Amplify or something. Everything's running here.
That's right.
On AWS.
That is correct, yes. Okay, so the CI/CD for the front end has been completed. Now let's go here and see if the change has been implemented. So let's say maybe sunny day. Yes, so emoji, now it's here, and then I keep my responses tasteful and avoid R-rated content, but I can offer display. Okay, so I guess it has been impacted by some of the changes that I made in the backend code. So yeah, this is how actually the CI/CD works for the Amplify as well as CodeBuild. So that is what my team is using currently to have a zero maintenance. And then let's, so all of the, if you need any reference or take a look at the code, how it works, then all of the link is provided in the slide. So takeaways, you can, with these approaches, you can build once and then deploy everywhere. There's zero ops CI/CD, and also there's, we covered end-to-end full stack application using 2 different AWS services. And then also both of the services are enterprise grade, scale and security, and also it optimizes the cost because you only pay for what you use. There's no fixed cost at all. Yeah, so that's it for me today. Any questions?
How would you expand the CI/CD pipeline to automate it, maybe automated tests?
Yeah, sorry, I'm sorry.
How would you expand the pipeline to integrate automated tests if you want unit?
Yes, that's a good question. Yeah, so with the Amplify, I haven't actually looked into more expanding it, but with the CodeBuild, it's just working like any CI/CD script, pipeline script. So you can actually write your unit test or linting or whatever. So it can be implemented there, but it's just going to be, instead of any Git specific CI/CD script, it's going to be just CodeBuild script that you write.
So it's specific CodeBuild script.
That is correct.
Do you add it as metadata to a YAML file or is it?
Yes, yeah, it is a YAML file. So if you take a look at here. So for the front end Amplify, the only thing that you have to specify is this. Then it will just cache it. It will artifact this. It will do everything for you. But with the, the CI/CD for the CodeBuild, this is the YAML syntax used by AWS CodeBuild. So it has, in GitHub Action, it has own CI/CD script syntax, right? For GitLab CI, it has its own CI/CD syntax as well. But the problem is you have one specific syntax. It's really expensive to migrate to another Git provider, right? But with a CodeBuild, you just move this file into another repo and it's going to work because it doesn't run within your Git provider's CI/CD runner. It's running on top of AWS, right? So that is the one advantage that I saw using CI/CD pipeline using CodeBuild.
And script is being allowed to GitHub.
That's correct. Yes.
I have a question, though I don't perceive myself as a web developer, though other people think that I am a web developer, so it's like a little bit of a gray area. So we build applications for Flask, and our repo is on GitLab,
Okay,
which provides some runners.
that's correct.
So I didn't know if, so we host on GitLab.com in a private repository. And we were thinking about whether we should move it to code.stanford.edu, which is also GitLab, but I don't know how runners are set up because I don't know if code.stanford.edu provide any visibility to do some CI/CD integrations in the site, do the testing, and then take it down. So I don't know if you're connecting it to separate. What I see is I think you're connecting with a separate AWS instance.
That is correct. Yes.
Did you ever try to run it on code.stanford.edu?
So right now it is all self-hosted GitLab instance, right? So the Stanford GitLab is not providing any integration with AWS yet. So that's why we wanted to leverage CodeBuild. So we moved to GitHub for that reason. And then with the GitHub, yeah, you can have integration with AWS seamlessly. Yes.
Okay. So with GitLab, so that's not a question about technology, that's more like what each service is providing. So GitLab.com is providing some integration with some server space just to make things easier, right?
Yeah, so GitLab.com is the cloud GitLab, right? And then code.stanford.edu is the self-hosted GitLab. So that is, so if you're using just GitLab.com, you can definitely use this approach, connecting to AWS CodeBuild and then run the CI/CD there without any maintaining it. But if you're using stanford.code.edu, then you have to have a self-hosted runner. There's no integration that you can make.
Now,
yeah.
It's not right out of the box.
That's right. It's not right off the box. Yes.
It would be nice to have it. We should make a suggestion at next UIT conference that it would be very helpful.
That's right.
There are lots of departments that are doing data research.
Yeah, I agree.
Well, thank you. That was
so thank you.
Very educational.
Okay, thank you.